All right, so you are getting out last time's notes, please. Okay, and then I think we only need to do maybe a little bit of it, and then we can go on to adding endpoints. Okay, the part that I want to do with you is this part right here. Do you need a new copy?
Well, it's because like 2 minutes ago, all my papers.
Oh no. Yeah, I think it's the one you did best. Isn't it? No. Does it have like U's all over it and stuff? Yeah, I think that's. Oh no, that's not it. That's not it. You're right. All right. Okay, so I'm gonna show you a little bit of a shortcut for you, sub. And then maybe you like it, maybe you don't. But let's think first about what we're undoing. Okay, the derivative of sine 4x. What's the derivative of sine? Cosine. Then do you remember you keep the 4x the same, but then you times by what? 4. Okay, so then what that means is when you go backwards on the integral of cosine 4x, okay, the 4 has to already be there for it to go back to sine 4x. Okay, so think about if that makes sense. That the derivative of sine 4x has an extra 4 in it. Then when I go backwards for the antiderivative, okay, that 4 has to already be there. So if you kind of don't like all the steps of U sub, okay, what you can think of is that if I'm doing, let's say, number 10, what would the U be? Okay, so the U is 7 minus 4x, then what's U prime? -4. Then here's what that means. There has to already be a -4 for us to undo the derivative. So you can think about putting a -4 on the inside. Then you'll divide a -4 on the outside. So if I need a -4 on the inside with the dx, then I would put a -1/4 on the outside to basically keep everything even. And then what's the integral of cosine? So it'd be -1/4 sine plus c. So kind of think about like with chain rule, you're multiplying by the derivative. So for undoing chain rule, it's kind of like you're dividing by whatever the derivative is. So if my derivative was a -4, then I would divide by a -4 on the outside to basically undo it. Okay, let's do another one. What's my U on number 11? 12 plus 5x. Then for 12 plus 5x, what's my derivative? A 5. Then I need to have a 5. Now, quick question. Do I already have a 5 in the -15? Yes. How could I split that up into multiplication? I could make it a -3 and then group the 5 in the back with the dx. So think about it, it's still -15, but I'm letting the 5 go to the back to be the derivative that has to already be there. And then what's the integral of negative sine? Snow cone, snow cone. If I'm on negative sine and I go up, I'd be at +3 cosine. 12x plus 5. Oh wait, 12 plus 5x plus c. Okay, but think about, remember what I said. It's kind of like you're just dividing by whatever your derivative is. So if my derivative is a 5 and I divide it on the -15, I still would have gotten this -3. Okay, last one. What's my U? 8x. What's the derivative of 8x? Just an 8. Then I have to have an 8. So I'm going to times by an 8 here and divide by an 8 on the 20. so that my 8 dx is already there for me to do the antiderivative. What is the antiderivative of tan squared? Or sorry, secant squared? Tan 8x plus c. And then in the front, I'd still have the 20 over 8, which you could easily reduce to 10/4. Oh, you could go even more. You're right. Good call. Okay. But let me just say, okay, that if this way is more confusing to you, then write out the steps for U sub and it'll always work. Okay, this is just kind of a more intuitive understanding of whatever the derivative is, you're basically just going to divide by it when you're undoing it. Okay, we're going to do, I think, just one more. Turn to number 17. It's on the last page. Okay, and these are not numbered well, so just turn to your last page. It goes from 17 to 20. Here's your dy dx. Notice it has x's and y's in it. So how am I going to separate the cosine 5y if it's divided on the right? Multiply it. So I'm going to multiply by cosine 5y here. And then I'm going to multiply the dx here. So now you have cosine 5y dy, and then 2x minus 1 squared dx. Okay, so step number 1 is to integrate or to separate. Then we put our integral on both sides. Now, this is important. Last time, we were only ever doing u sub on either the x or the y. Okay, where will we need u sub on this one? On both sides. So the u sub on the left, what will my u be? 5y, and what will it be on the right? 2x minus 1. So you can do it, you'll just work both sides out separately. Let's do the x side first. What's my u we said? 2x minus 1. Then du dx is the derivative of that. Which is what? 2. Then remember, I multiply the dx up, and I divide the 2 down, so that my du over 2 is going to replace my dx. Okay, then remember, we're going to rewrite our integral. My 2x minus 1 is a u now. Keep this squared on it. And then my dx is going to be subbed out for a du over 2. And if it's a divide by 2, what can I pull to the front? Should be a fraction. 1/2. So I have 1/2 u squared. 1/2 u squared du. All right, we're ready to take the antiderivative. U squared goes to what? U cubed. And then after I add 1, I have to divide that on what's already in the front. So I need to divide by 3, but I already have a 1/2. Well, then I want 1/2 of a 1/3. And what do I do with those fractions side by side? Multiply straight across the top, straight across the bottom. So 1 times 1 is 1, 2 times 3 is 6. Okay, then I'm going to take my u, which is this 2x minus 1. And I'm going to just, oh, you're welcome. Okay, put your 2x minus 1 back in cubed plus. All right, we're done with the x side. Now we need to do the y side, but we're going to have to pick a different u. So what did we say our u will be on the other side? 5y. Then du dy is going to be the derivative of 5y, which is what? 5. Then I'm going to multiply the dy up, divide the 5 down, so that a du over 5 is going to replace the dy on the left-hand side. So my cosine 5y is now a cosine u. And my dy is now a du over 5. And then just like on the other side, I'm going to take that 5, pull it up to the front. What fraction would I have in front? 1/5 cosine u d. Okay, think snow cone, snow cone. What does cosine go back to for an antiderivative? Sine. Okay, remember no plus c on the left side because we already put it on the right. And then we're going to turn that back into our 5y. So it'd be 1/5 sine 5y equal to this. Okay, after I've done the integral on both sides, what is my goal next with this y? Yeah, we need to basically get the y alone. So to get rid of the 1/5, that's a divide by 5. We're going to do what? Multiply. So I'm going to times by 5 here and here. Remember, technically, I am also multiplying the c, but we just don't care. So 5 and 1/5 are gone. Sine 5y equals 5 times 1/6 is now a 5/6. What would my next step be to get rid of the sign in the front? Do you remember from pre-calc? How do I cross out just the sign if I'm trying to get 5y alone? Inverse sign. Remember the sign with the little -1? That cancels it out. So you'll put sine -1 here, sine -1 here. Okay, but remember that stands for inverse sine. Now, one problem that I saw on y'all's test is that some of y'all, when you did it, you just did this. Okay, obviously there wasn't a sign, but there was I think an ln or something. What has to be around this? Parentheses, here's why. The c is also inside the inverse sign. So this whole side needs to go inside what you're applying to the other side. The c is not separate from that. Okay, and then how do I get rid of the 5 in the front? Divide by 5. So I'm just going to apply a 1/5 and call it a day, so I don't have to rewrite it. Okay, overall, we get the idea? Okay, so our main goal for today is just to add endpoints. So when you're ready, take a look at today's notes. And I want you to start number 1. So you should already know how to do U sub. So start number 1. You're going to pick your U, take your derivative, and solve for dx, just like we did last class. Are you all done with this? So somebody tell me, what are we picking as our U? X squared minus 1. Now remember, your U needs to be inside stuff. Okay, so if that's my U, it's inside the cubed power. Okay, du dx is the derivative. What's the derivative of x squared minus 1? Just a 2x. Then remember, I'm going to multiply the dx up and divide the 2x down so that it'll be a du over 2x that replaces my dx. Then remember, this and this are going to substitute in my integral. So I have the integral of 12x. Then this little part here I squiggle underlined is my u cubed. And then my dx is going in as a du over 2x. Okay, in this step, any x's should be gone. Are these x's gonna be gone? Yes, because if you have an x on top and on bottom, those can cross out. Then remember the remaining numbers, just divide them with each other. So 12 divided by 2, what is that gonna be? 6u cubed. All right, now we're ready to take the antiderivative. Remember, we're going to add 1 to the power, then divide it to the front. So u3 is going to go to u4. And then I'm going to have to divide by 4 on the 6. So now it's a 6/4. Now, why do I have to put those brackets? Because what do I have on this integral that we didn't have on Monday? The endpoint. So let me remind you at the top of your paper, if you have an integral with numbers in these spots, you take the antiderivative, so little f goes to big F, then you plug in the top and the bottom numbers, and then you subtract them to get your final answer. So that's exactly what we're going to do here, but before we need to switch back to x's. So this is really going to be, let's reduce that 6/4 to a 3/2. My u is an x squared minus 1 to the 4th power plus c. And then from there, I'm going to find capital F of 2, capital F of 0, and then subtract. Let's start with 2. What is 2 squared? We're taking our 2, we're plugging it into this spot. 4. And then what's 4 minus 1? So I have 3/2 of 3 to the 4th. And then 3 to the 4th, think about 3 times 3 is 9. The other 3 times 3 is 9. And then if I times the 9s together, how much is it? 81. So that's 3/2 of 81. And I'm just going to leave it like that for now. Now let's plug in our 0. 0 squared is 0. What's 0 minus 1? So then I want 3/2 of -1 to the 4th. What will -1 to the 4th power be? +1. So this is 3/2 of 1. Okay, then remember, I want to do this minus this. So my final answer, I guess we're not doing number 2 because I wrote 2, is going to be 3/2 of 81, bless you, minus 3/2 of 1. Okay, now you should notice that both of those have a 3/2 in them. Then I can GCF that out. So my 3/2 is going to come out, leaving me with what subtraction when I GCF it out? 81 minus 1, which is how many? Then really, I want 3/2 of 80. And then remember, the order that you do this doesn't matter. I'm going to do 80 divided by 2 first, which is how much? Then times it by 3, 120. Okay. We are going to do one more like that. Go ahead and turn page. Let's do number 4. Okay, take a look at number 4. What u do you think you should choose?
Wait.
Okay, good. Now, why are we not including the e? Yeah, because the u needs to be inside something. So right now, the u is inside the e, but if you pick the e too, then they're not inside anything. Okay, so remember, you want it to be the middle layer. Then what is du dx? The derivative of 6 would just go to 0. What's the derivative of minus 2x? Okay, then multiply your dx up. Divide your -2 down. And dx is going to be replaced by a du over -2. Then we're going to rewrite our integral. E to the u because my 6 minus 2x is getting swapped, and my dx is now a du over negative 2. Take your minus 2, pull it to the front. What fraction do I have in front of my e now? Negative 1/2 e to the u. Okay, now what is the antiderivative of e to the u? Remember, e is its own derivative and its own antiderivative. So I'm going to have a minus 1/2 e to the u. And then before I plug in, I have to go all the way back to my original x stuff. So I'm going to take my 6 minus 2x and plug it in right there. Okay, but notice the reason that we have those brackets is because we have endpoints. Then we're going to find capital F at the top endpoint, which was a 2. And then capital F at. Let's do the 2 first. Right here, I'm plugging in a 2 next to into the x position. What's 2 times 2? 4. And then what's 6 minus 4? So I have negative 1/2 e to the 2. Next one, we're plugging in a 0. So my 0 is going to go right there. 2 times 0 is 0. Take it away from 6. What's going to be left? Negative 1/2 e to the 6. Okay, then remember, it's top minus bottom. So for my answer, it's negative 1/2 e squared minus negative 1/2 e to the 6. And then what's going to happen if you're minusing a negative bottom number? That's really a what? A plus or an aggregate. Okay, do they have a GCF that I could take out? They both have 1/2. That leaves me with a negative e squared and a plus e to the 6. Now, although this is right, typically on the AP test, if you have a negative plus something, they're going to just reverse the order. So they would put that this is really 1/2 e6 minus e squared. Okay, but you should be able to tell that those are equivalent. Okay, as long as your e squared stays negative, it doesn't matter if you flip-flop the word. Make sense? Okay, I'm going to show you a shortcut that you do kind of have to understand, but if you like this method, that's totally fine. You'll be able to use it on 90% of the questions the AP test will ask you to do. Okay, so go up to number 3. We're going to start off the same. So put a little star here. This is going to be solved slightly differently. What do you think you should pick as your u? Okay, x to the 4 plus 1. And then remember, why am I picking that? Because it's inside the square. What is my du dx? The derivative of that. For x3. Then I'm going to bring my dx up and divide my 4x3 down. When I do my substitution, remember, it's the top and the bottom that are going to swap out this and this in my integral. So my 24x cubed is still there. But this is now a u squared and then a du over 4x cubed. What has to happen in this step to your x's? Have to cancel out, which they do, because I have an x3 on top and an x3 on bottom. Okay, then out of the numbers that are left, what's 24 divided by 4? So this is really a 6u squared d. Okay, at this point, what our method is going to be is that let's say that we never want to go back to x. We want this entire substitution to never have to go back to the x stuff. Then what you're gonna do is you're gonna change your endpoints by plugging them in into the u equals x4 plus 1. And that's going to give you new endpoints that you can use on your integral so that you never have to go back to x. So what was my original top endpoint? What number? It used to be a 1. Then I'm going to take that 1, I'm going to plug it into this formula, and that's going to be my new top endpoint. So what is 1 to the 4th plus 1? The new top endpoint is a 2. And we're never going to go back to x. My original bottom endpoint was what number? A 0. Then what's 0 to the 4th plus 1?
1.
Be a 1. And now I can just do this antiderivative as a u and never go back to plugging that in. What's the antiderivative of 6u squared? So my u goes to a cubed. I divide the 3 on the 6. Now it's a 2. And then I'm going to plug in the 2 and the 1. What is 2 cubed? 8 times 2, 16. On the bottom, I would do the 1 cubed first, which is times it by 2. And then I'm going to do top minus bottom, 16 minus 2. My answer is 14. Okay, but I want you to think about logically why that works. That if I had put this x plus 4 into that spot, I would have still gotten the same answers here. It just makes this not look quite as bad. Okay? All right, turn the page. We're going to do one more like that. Take a look at number 5. Uh-huh. Okay, 5 and 6 are the same, so we're just doing the top one. What do you think you should pick as your u? 3x plus 2. du dx is the derivative of 3x plus 2, which is what? Just a 3. Then you're going to times the dx up, divide the 3 down, so that where my dx is, I'm going to replace it with a du over 3. Let's rewrite our integral. I have a 9 on top. My 3x plus 2 is now a u. And then my dx is a du over. What is 9 divided by 3 for the front number? So this is really 3 over u du. Question, should I try to use a negative power on this? Like try to pull it up? No, this is a special. What do I do when I have a u on the bottom? What do I get when I do the integral? Natural log. So I'm going to rewrite it. That's the same as 1 over u multiplied by a 3. And then we know that our 1 over u is going to go to n. Okay, don't forget the bars. Now, let's say I'm not trying to take this 3x plus 2 and plug it back in here because it's going to make this ugly. Then what I can do is take my original endpoints, plug them into u, and then whatever those numbers are, those are going to be my new endpoints. So my original top endpoint was a 4. Plug it in right here. What's 3 times 4? Plus 2. Then my new top endpoint is a 14. On the bottom, what was my original endpoint? Was a 0. Then I'm going to plug into right here. Oops, don't put a 0 there. plug it in right here. What's 3 times 0? 0 plus 2. Then this is now a 2. So my new endpoints are a 14 on top and a 2 on bottom. But if you change your endpoints, you never have to go back to x. Okay, let's plug them in. 14 plugged in is going to be 3 ln absolute value 14. Bottom endpoint is 3 ln absolute value 2. If I have a positive number already, do I need those absolute value bars? So really, for my final answer, it's going to be 3 ln 14 minus 3 ln 2. What should I do to my answer from there? Take out the 3. That leaves me with the natural log of 14 minus the natural log of 2. And then does anybody remember what you can do to these with logs? If you have logs that are subtracted, how can you put them into the same ln? Divide these numbers. Okay, so 14 divided by 2, that would go to ln 7. Okay. All right, go ahead and turn the page. Okay, number 7 and 8 are asking you to find average value. Now, we're only going to work number 8, okay, just to shorten these up. But average value is a formula. Okay, so the average value is 1 over b minus a integral a to b. Okay, so that's a formula that you have on one of your study sheets from one of your tests. When we get closer to the AP test, we'll kind of review what you should try to remember. Okay, but average values, 1 over b minus a, integral a to b. So take number 8, and I want you to fill that out. So it says, find the average value on 0, pi halves. That's my a and my b for my interval. So then what would my fraction in the front say if it's 1 over b minus a? 1 over pi halves minus 0. And then the integral from 0 to pi halves of my function, which I'm going to rewrite like this. Okay, that if it's a sine cubed, that really means the whole sine x is. So looking at it, what am I going to pick as my u here? Sine x, because what's it inside of? The cubed. So my u is a sine x. What does that make my du dx? Derivative of sine is cosine. Then I'm going to multiply my dx up and divide my cosine down. So a du over cosine x is going to replace dx right here. And then if you kind of think ahead, that's good, right? Because I have a cosine I need to get rid of, and I have a divide by cosine on the bottom. So this is now going to be a u cubed. My cosine's still here for now. But then when I replace my dx with my du over cosine x, now those are going to be gone. What is the antiderivative of u cubed? So u will go to the 4th, and then I'll have to do a divide by 4. Okay, don't forget, technically there's a plus c. And now let's do a little bit of work on this fraction in the front that I kind of forgot about. What is pi halves take away 0? It would just be what? Pi halves. And what do you do when you're dividing by a fraction. You just flip it. So if I'm dividing by pi over 2, that means I'm really multiplying by a 2 over pi. Okay, then at this point, I have two choices. I can either go back to my x, or I can change my endpoints to not have to go back. So I'm going to go ahead and change it. Thank you. Dawson is for you. Okay, so my 2 over 4, let's go ahead and reduce that to a half. So it's going to be 1 over 2 pi. And then I don't know which method you like better, but I'm going to change that rather than go back to x. So if my u is sine, what was my original top endpoint? Pi over 2, then which finger is that on your hand? So 0, pi 6, pi 4ths, pi 3rds, pi halves, fold it down. And then sine is your down fingers. How many are there? So it's root 4 over 2, which is 2 over 2, which divides 2. So my new top endpoint is just a 1. On the bottom, I'm plugging in a 0. Sine of 0 would be which finger? Bottom finger. How many fingers are below your pinky? 0. And then you're going to take those, plug them in, and subtract. So if I do my 1 first, what's 1 to the 4th power? Still 1. Times it by 1 over 2 pi. And it would just be a 1 over 2 pi. Plug in the 0. What's 0 to the 4th? Still 0. And 0 times anything is 0. Then remember, I do this minus that. My final answer will be 1 over 2 pi. Okay, because if you subtract those, obviously the 0 doesn't matter. Okay? All right. Last thing we're going to do is I'm going to show you why you have to understand the endpoint change. So turn to number 7. This is the last page. Oh, I don't know how to number stuff. It's fine. Yes? I know. I don't know why I do that. Okay, take a look at it. You have an integral right here. And they're asking you which of these integrals is equivalent. So what you basically need to do is use substitution and then see which of these is the same. So give it a shot. They're even telling you what to pick as your u. So I know my u needs to be an x squared plus 1. Then go through your steps and see if you can pick which one of these is the same. So your u is an x squared plus 1. What would your du dx be? 2x. Then I'm going to times my dx up, divide my 2x down. And then I'm going to come in here to my integral that they're asking me to do. I'm going to leave the 8x alone. But my e to that stuff is now an e to the u. And my dx is now a what? Du over 2x. And then what needs to happen with those x's? Cancel out. 8 divided by 2 gives me 4e to the u. Now, look at your answer choices. They're not even asking you to solve it. They just want to know which one's the same. So right now, which 2 answers can I get rid of? I need to have a 4e to the u. A and D are gone. Okay, but then if you look at your endpoints, how can I switch my endpoints over to you? I'm gonna take the originals, plug them in here to know my new endpoints. So if I had a 3, what's 3 squared? Plus 1? Then it has to be C. Okay, but don't forget to change your endpoints if you're gonna leave your integral as a U. Do we need to do another one or are you good?
No, we're good.
Okay, there are 2 of these at the bottom of your homework if you want to try those first. You have about 50 minutes. Okay, so let's try to get as much of our homework done as we can. You can do it.
No.
Are you going home?
I don't think so, but I hope so.
Go on some scratch paper. We good? Good. That means we're planning to work. What? Oh, it's okay. What's up? There you go. Gonna take it. What about you? Little paper? There you go. Perfect. Thank you. So you need paper? Yes, sir. So the new one is the one, and then if you need to go back and work on one.
Bad for you. For all of it, we need a place like.
Yeah, and maybe a little bit. So I would say maybe for now, work on the new one, and then maybe we'll do a level.
What up, Bear? We're not talking to you. Dude, I don't know. I don't know what's happening here, bro. I'm so lost.
Y'all want paper? Really, it's kind of the same. We just added it. Yeah. So much today.
Yeah, wow.
Let's do some homework.
Log in.
Good. All right. That's what I like to hear. I feel like when I say one more, it's like I just can't stop it. Like sometimes I know like maybe this. But it's never the last. Oh, good. I'm glad I'm not alone there.
You're not getting 5.